Day 538 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3461. Check if digits are equal in string after operations 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out the link in the description so you can get you some. Now let's see what the question says. You are given a string S consisting of digits. Perform the following operation repeatedly until the string has exactly 2 digits. For each pair of consecutive digits in S, starting from the first digit, calculate a new digit as the sum of the 2 digits modulo 10. Replace S with the sequence of newly calculated digits, maintaining the order in which they are computed. Return true if the final 2 digits in S are the same, otherwise return false. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input S equals a string 3902. The output is true. The explanation says initially we have S, which equals the string 3902. The first operation, well, let me bring this over here so we could go through it. The first operation is S of 0 plus S of 1 mod 10, which is equal to 3 plus 9 mod 10, which equals 2. So first thing we do, we take the first 2 digits because it says right here, for each pair of consecutive digits in S starting from the first digit. So these are the first pair of consecutive digits starting from the first digit, 3 and 9. So we take 3 and 9 and we could just copy and paste this. We take 3 and 9, and then so 3 plus 9 equals 12, and when we divide 12 by 10, we get a remainder of 2. So all this is doing is dividing by 10, and then, sorry y'all, all this is doing is dividing by 10 and then returning the remainder. So 3 plus 9 is 12. When we divide that by 10, we get a remainder of 2. So that's what we're looking for, what the remainder is. Boom. Then we do the same thing for the next 2 digits, which is S of 1 and S of 2, which is this 9 and 0. So we're just moving down. First we did these 2 digits. Now we're moving down. We're doing these 2 digits. And these 2 digits is the same principle. Boom. Let me just copy and paste this again. So 10 S of 1 stands for index 1 of S, which would be 9, and index 2 of S would be 0. So 9 plus 0 will give us 9. Divide that by 10, it'll have a remainder of 9. Boom. Then we do the same thing again for the next 2 digits. So for 2 and 3, which would be these 2 right here. So once again, we just copy and paste this over here. Boom. Then we do the same thing. We do 0 plus 2, which is going to give us 2 divided by 10. We still have that remainder of 2. Boom. But we're not done yet because we need to do it again, right? We need to do it on. So right now we have 292. So the new array would be 292. So each time we do this, just imagine it says right here, replace S with the sequence of the new calculated digits. So after we replace S with the new calculated digits, we get this and we do the same thing again. So now we do the same thing, S of 0 plus S of 1, copy and paste that. So all that is this 2 and this 9 we're doing now. 2 plus 9, 11. Divide that by 10, we have a remainder of 1. Then we do it again for the 9 and the 2. So let me bring this over here. So now we just did it for these, the 2 and the 9. Now we're doing it for the 9 and the 2. And once again, 9 plus 2 is 11. Divide that by 10, have a remainder of 11. So the final output would be 11. And it says return true if the final 2 digits in S are the same. So in this case, the final 2 digits are 11 and the digits are the same. They're both ones. And then it says return false otherwise. Remember, we repeated this until the string has exactly 2 digits. That's why we kept going after this until we got left with this. Or just so it makes sense, it would look more like we could just put it like this. But either way, this was the final output. And sorry, y'all, it would be a string, not an array. So I'm wrong for making it an array. So let's just make it a string, so it's correct. Boom. So this is what it would look like in the end. And since 11 has the same two digits, then we return true. So let's take a look at example 2. Example 2 are the same principles apply. We're not going to go through it like we did the first one, but we are going to read through it. If you, I suggest you try to break it down on your own if you're still having problems with it so you can better understand it. But in example 2, we have the input S equals a string 34,789. The output is false. Initially, we have S equals the string 34,789. After the first operation, we get S equals 7,157. After the second operation, S equals 862. After the third operation, S equals 48. And since we get to 48, and these are the last two digits, and they are not the same, right? Since 4 does not equal 8, the output is false, and that's how we got false. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we want to convert our input string into an array of integer digits. So we're going to come right here. We're going to declare a variable called array and set that equal to s.compact map. Open up the parentheses. We're going to say slash dot whole number value. So all this whole number value is going to do is it's a Swift property on the character type that returns the integer value of a character if it represents a digit between 0 and 9. Otherwise, it's just going to return nil. Boom. Now we need to continue reducing the array until only 2 elements remain, and each iteration is going to build a new array in place by summing adjacent digits modulo 10. So we're going to say, come underneath this, we're going to say while array.count is greater than 2, we're going to open up the brackets. And for every pair of adjacent digits starting from index 1, we're going to replace the element of index minus 1 with the sum of itself and the neighbor modulo 10. So we're going to say for index in 1 dot dot less than array dot count. We're going to open up the brackets and we're going to say array square bracket index minus 1. Come outside of that, we're going to say equals, open up the parentheses, array square bracket index minus 1. Come outside of that square bracket, we're going to say plus array square bracket index. Come outside the parentheses and we're going to say mod 10. Boom. Then after processing, we're going to remove the last element since we have already merged it by coming underneath here, and we can say array.remove last, then put the parentheses. And finally, we're going to compare the first and last remaining digits. If they're the same, we're going to return true. Otherwise, we're going to return false. And we can do that by coming right here, and we can say return array.first is equal to array.last. So once again, this is a Boolean. It's going to return true or false. If this statement holds true, then it will return true. If this statement does not hold true, then it will return false, y'all. And that's all she wrote. So let's go ahead and give it a run before we submit it to make sure it runs correctly. It's accepted, so let's go ahead and submit it now that we know that it runs properly. And look at that, y'all. 3 milliseconds beats 77.78% of users. Not too bad, not too bad at all. Those are some good numbers right there. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.